we look at ordered pairs, remember looking at X is an element of A, right? So when we had the sets. Now let's take a look at X comma Y is an element of A paired with B. The difference is now instead of one variable, we have two variable, and it's going to be an element of this weird combination that we're going to call the Cartesian cross product. The ordered pair AB is in place of just A or just B. I like this one. Two ordered pairs to be equal, then A has to equal C and B has to equal D. That's pretty obvious. Is it possible for AB to equal BA? Is that possible? How? A equal B, yeah. So if A is equal to B. Cartesian, whenever you see A cross B, it's the set of the ordered pair A comma B. So you have two variables. A is an element of capital A and B is a capital element of capital B. This is how we look at ordered pairs, and the dimension of it, we don't have to do it A comma B. We can do A comma B comma C. We can have as many dimensions as we want, but we define it with the squared, the Cartesian plane of those two. So let's take a look at 1, 2, 3. 1, 2, 3 pairing with 5, 6. And we want to look at all the members of that set. Can you see how it's going to be a whole bunch of things? 1, 5, 2, 5, 3, 5, and 1, 6, 2, 6, and 3, 6. So from this A, this is A, and this is B, how many of those pairs are we going to have? Just by looking at this 3 and this 2, how many are you going to have? 6 of them. So idea here is that the number of A cross B that you're going to have will be the number of A times the number of B. There's your 3 times 2 is 6. And you can show that. Well, we're going to prove that the Cartesian product is distributive. And the way you're going to do this is, would everybody go to this guy? I want to make sure that you're feeling confident about the notation. This whole thing is exactly what we did before. So Ben, you with us? Doing all right? So here's what we start with. You're going to start with the blue. X. What's different though? X isn't an element of the blue. What is? XY. So the difference is that X maps to the first part and Y maps to the second part. So that's how we get the X is an element of A and Y is an element of B intersects C. This cross here is saying and. So X is an element of the first part, Y is an element of the second part after the X, or the cross. And so we have X is an element of A, Y is an element of B, and because of the intersection, Y is an element of C. So if you look at this, look how the X is connected just to A, but the Y is connected to, the Y is connected to both B and C. So we're going to have X comma Y is an element of A cross B, and X comma Y is going to be connected to A cross C, because you get X and Y giving you A and B, and X and Y is A and C. So with this little and, you can change that to the intersection, and you get A cross B intersect A cross C. So we did it. We got A cross B intersect C equal to this. And so then we said that it's a subset. Same old thing. Now we're going to do it in reverse. X, Y, element of A cross B, intersect A cross C. So now we're going to start with the end. Y is an element. So X pairs with the first part, A cross B. Y pairs with the second part, A cross C. And then you break those up. X is an element of A in both cases. And then Y is an element of B, and Y is an element of C. So you can see how those connect to the intersection, and X element of A and Y is an element of B intersects C. And so you can put those together, A cross B intersects C, and there you've got the second part. Second implies the first, first implies the second, so they're equal. What do you think? It's not too scary, just a little weird. So I'm going to turn you loose on these right away. You're going to do the A cross B and B cross A for these. And this is going to be easy, just setting up the drawing. And then number 3 here is to do the proof. I'm going to have you start with the proof and give you just a couple minutes to do this.